Hello students, welcome to Eshwari Thaniksha channel. In this video, we are going to see the important formulas from the chapter solution which will be used in calculating the numericals. I'll teach you a few numericals as well, how to solve using the formula. So let us see the formula one by one. So students, before going into the video, if you are new to our channel, don't forget to subscribe our channel. All important numericals will be taught in this channel, and that too in a simplest way. So you can follow our channel. It will be very useful for your NEET preparation. So let us see the first formula. The first formula is delta P divided by P naught is equal to P naught minus PS by P naught. So what is P naught? P naught is called as vapor pressure of solvent. PS is called as vapor pressure of the solution. So here P naught minus PS by P naught is called as relative lowering of vapor pressure, which is one of the colligative property. Second formula, delta P by P naught is equal to mole fraction of the solute. So here this symbol indicates it is the mole fraction. So here if you want to calculate mole fraction of the solute, you have to use this formula. In the NEET examination, you can see calculate mole fraction of the solute. So these values will be given and you have to calculate mole fraction of the solute. Use this formula directly, you will get the answer. Next formula is, suppose if you want to calculate mole fraction of the solvent, use this formula, that is PS by P naught. What is PS? PS is already given here, which is vapor pressure of the solution. P naught is called as vapor pressure of the pure solvent. So use this formula directly, you can get the answer. Fourth one is delta P by P naught is equal to number of moles of solute divided by number of moles of solvent. Again, in NEET examination, you can see this type of questions will be asked. Find the number of moles of solute. So all these values will be given. You have to find out the number of moles of solute. And then next is P naught minus PS by P naught. So this is relative lowering of vapor pressure is equal to W2 into M1 divided by M2 into W1. So what is W2 here? W2 is called as weight of the solute. M2 is called as molar mass of the solute. W1 is called as weight of the solvent. M1 is called as molar mass of the solvent. And this equation is for dilute solution. So in the question, if you see, if it is a dilute solution, use this and directly you will be getting the answer. Whereas if it is concentrated, then answer might slightly vary. Therefore, it is recommended in NEET and JEE examination, we are going to use this formula. There is slight change. Instead of P naught, we are going to use here PS. P naught minus PS divided by PS is equal to W2 divided by M2 into M1 by W1. So this is the formula we are going to use. And then next formula, suppose molality, very important question. Suppose molality is given. So you want to find out relative lowering of vapor pressure. Delta P by PS is nothing but relative lowering of vapor pressure. So let me write here. So this is nothing but relative lowering of vapor pressure. So relative lowering of vapor pressure is equal to molality into molar mass of the solvent into I. I is called as Van Hoff factor. Small m is molality, capital M is molar mass, and I is called as Van Hoff factor. So using this formula, I will show you one question how to solve. So let us take this question now. So first let us write what is given in the question. So given. So you can see here the vapor pressure of pure benzene at a certain temperature is 0.850 bar. So what is given is vapor pressure of pure benzene. Pure benzene meaning is here they have given vapor pressure of pure solvent P naught is equal to 0.850. And then a non-volatile, non-electrolyte solid weighing 0.5 gram, that is weight of solute W2 is given as 0.5 grams. Is added to 39 grams of benzene. So weight of solvent is given as 39.0 gram benzene. And molar mass of benzene is given as 78. So M1 is given as 78 gram per mole. And then vapor pressure of solution is given as 0.845. So PS, vapor pressure of solution, is given as is given as 0.845 bar. So this is pressure is in bar. So what you have to find is what is the molar mass of solid substance, that is M2 you have to find. So this is the question. So which formula you are going to use here? So you can see here P0 is given, PS is given, W2, W1, M1 is given, M2 you have to find. So you can use this formula. P0 minus PS divided by P0 is equal to W2 by M2 into M1 by W1. So let us write the formula. P0 minus PS divided by P0 is equal to W2 by M2 into W1 into M1 by W1. So this is the formula. So now substitute in this equation. So what is P0? P0 is 0.850. 0.850 minus 0.8, how much it is given? 845. 5 divided by 0.850 is equal to W2 is given as 0.5 into M1 is given as 78. 78 divided by M2 you should find into W1 is 39. So we have substituted. So in the next step what we are going to do is M2 shift to the other side, or first we will subtract this. When you subtract this you will be getting 0.005 divided by 0.850 is equal to 0.5 into 78 divided by M2 into 39. So now let us shift M2 to the other side. So you will be getting M2 is equal to 0.5 into 78 divided by 39 into, shift this terms also to the other side. So this one will come in the denominator and this will go to the numerator. So 0.850 divided by 0.005. So now let us cancel this. So now 13 3s are 39. 13 3s are 39 and then 13 6s are 78. 3 1s are 3, 3 2s are 6. So now what we can do is shift this point. After point there are 3 digits. So you will get into 10 to the power of minus 3. So here also after point there are 3 digits. So if I shift the point you will be getting into 10 to the power of minus 3. So in the numerator also 10 to the power of minus 3 both will get cancelled. So you can remove the decimal. So this is equal to 0.5 into 2 into 850 divided by 5. So now, so let me write here on the other side. So M2 is equal to 0.5 into 2 into 850 divided by 5. So this is what we got. So cancel this, 5 ones are 5 ones are. So this is equal to 0.1 into 2 into 850. So this is equal to, so multiply this 2 and see how much you will get. 850 into 2. So you will be getting 2 zeros are 0, 5 2s are 10, 8 2s are 16, 1 17. So you will be getting 1700 into 0.1. So if you multiply this, so this is equal to 170.0 you will be getting. So 170.0 gram per mole. So this is the final answer. M2 is equal to, you will be getting this answer. So students, is this simple? So easily stepwise we have solved the question. So next question we will solve now. So this is related to molality. See here molality is given. Calculate vapor pressure of 1 molar aqueous urea solution at 25 degree Celsius. So what you have to calculate is vapor pressure of solution you have to calculate. So molality, if it is given, which formula we are going to use? We are going to use this formula where molality is given and also vapor pressure of solution is present. So let us write that formula. So formula we are going to use here, P naught minus PS, or let me write the same formula, what I have given here, delta P by PS. So here delta P by PS is equal to molality, molar mass of solvent, into I, Van 't Hoff factor, divided by 1000. So delta P is nothing but P naught minus PS is called as delta P, divided by PS is equal to molality. What is molality given here? In the question you can see it is 1 molar. So 1 into molar mass of solvent. So here solvent is aqueous. Aqueous means it is water. What is the molar mass of solvent? H2O if you take. So there are 2 hydrogens. So 2 plus oxygen is 16. So this is equal to 18. 18 is the molar mass. So 18 into Van 't Hoff factor. So what is I here? Van 't Hoff factor for urea. So what is Van 't Hoff factor for urea? So already I have made a beautiful video on Van 't Hoff factor. So how to find the Van 't Hoff factor for urea, then glucose, sucrose, if any ion is given, strong electrolyte, that is strong acid, strong base, weak acid, weak base, if it is given, how to find the Van 't Hoff factor I have given. So for urea, which is a non-electrolyte, I value, that is Van 't Hoff factor, will be equal to 1. So into 1 divided by 1000. So now and also in the question, vapor pressure of 1 molar aqueous urea solution at 25 degrees Celsius is given, and P naught value should be given in the question. So take down P naught value. So P naught value is equal to 24 torr. So this is given in the question. So let us substitute this. So P naught is 24 minus PS we need to calculate, divided by PS is equal to 18 divided by 1000. So correct. Next step what we are going to do is 24 minus PS divided by PS is equal to 0.018. So what we have done is, here 3 zeros are there. So count 3 numbers, 1, 2, 3, and then put point. So 0.018 we got. So in the next step what we are going to do is shift this PS to the other side. Take this to the other side. So we will be getting 24 minus PS is equal to 0.018 PS. So next step, 24 is equal to 0.018 PS plus PS. So what we have done is minus PS we have shifted to other side. So it becomes plus PS. So now add this. So here 0.018 plus 1. So it will be 1.018 PS you will be getting. 24 is equal to. So next step we can write PS is equal to 24 divided by 1.018. So now you divide this. So when you divide this you will be getting 23.57 torr. So vapor pressure of solution will be equal to 23.57 torr. So this is the answer. So in the question what and all will be given is, they will give P naught. So molality is given. So what you have to find out is mole vapor pressure of the solvent. So you should only find out Van 't Hoff factor. So learn to find out the Van 't Hoff factor for different kind of the solute. If it is strong electrolyte, if it is weak electrolyte, how to find that you should know. So using these values we can easily use this formula, make a note of this formula. So we can easily find out the vapor pressure of the solution. So students, is that clear? So if you have any doubts you can write in the comment section. I'll meet you in the next video, students.